Now this is the tempering process where we are increasing the strength in the glass. Earlier whatever we have seen, basically we were dealing with annealed or raw glass where the strength of the glass is very weak. Now we are going to increase the strength of this glass by heating and cooling. So basically we are enhancing the mechanical properties of the glass through tempering process, and we are not changing the physical properties of the glass. Here we need to see the height and width basically in order to avoid the distortion. So first we will measure the size of the glass. If you see, it is 1460. This is my order where I require, this is the order where I require my glass has to be heat strengthened and heat strengthened. Now I am processing 6 mm clear glass and the width is 1459. And my height is 2243. 2244 it is coming. 1 mm, okay. Now we are going to differentiate. Through the help of logo, we are going to identify whether the glass has been tempered or not. Now you see, this logo describes that it is a Fusomec and it is a heat strengthened glass. Okay. Always we send width parallel to furnace. This is the first screen where they are going to get the top and bottom temperatures, timings, pressures, all these things. Next. Now they are going to keep preheating furnace parameters. Okay, next. Now they are going to give heating furnace parameters. Next. Now you can see the convection motor parameters for the preheating furnace they are setting. This is a top convection parameter. Next. You see this is a top convection parameter set. Again the second thing. Next. Now you can see this is the quenching parameters. Okay, next. Now you see this is the cooling parameters what they are going to give. Next. And if you see this is the balancing parameters what they are going to keep. Quenching pressure balancing parameters. Next. Now you see again the cooling pressure balancing parameters. Next. This is the overall. Okay. If you see this is talks about the heaters, top heaters as well as the bottom. This slide shows the top heaters and the next slide shows the bottom heaters. Okay, next. What? Okay. Next. Okay, next. This is the overall glass parameters. Now they are using 6 mm thick glass. These are the parameters you can keep. These are, it will automatically save the feedback what we are giving. Next. This is, you can see the chart showing the heating. This is a time versus heat chart. Next. You can see the overall settings of this particular glass. Already went inside, huh? Wait. Which will be able to, this one will help us to trace the glass. Now you see the glass is going inside the furnace where the glass will be done heating. Sit down and zoom. So now the glass is inside the furnace where the preheating will be done. The preheating will ensure the quality of the product. Next it goes to the secondary heating section, and after that the glass moves into quenching section where with the help of nozzles cool air is blown onto the glass. In this furnace we can make two types of products. One is heat strengthened glass and one more is toughened glass. You will get a toughened glass when rapid cooling or quenching is done on the glass, whereas a gradual cooling will result in the heat strengthening of the glass. Now you can see there are nozzles on the glass. You can find the nozzles in the quenching area. Through that nozzles the cool air will be coming onto the glass. You can see now the glass has entered into the quenching section. You open and possible open. Sit down. From back you take. Now the glass is in quenching section, where the glass will be oscillated uniformly.
You do the fragmentation zebra test of it.
You take a blower out. Now come this side. Now the glass is moving at this particular place, and the next glass is already inside the furnace. You see, this is the loading, this is the quenching area, one more glass is there, this is the second glass, it is the exit unloading point. Now the glass will come. Right. Now we need to understand the zebra board onto the glass. We need to see the zebra board onto the glass to check the distortion levels. So that image you see on the glass. All four glasses. So this is one way of visual inspection through zebra board for a heat treated glass. Now we are going to, this is one way of, at the time of unloading we will be checking for the glass having bend or bow. You see from this edge to that edge. From this edge to that edge you can find what is the bend level inside the glass. So in between there is dirty glass. Now you see the straightness of the glass. Glass is having any bend or bow that we can check at the time of unloading. And always there should be an interleaving between the glass at the time of stacking. if you have three glasses, one is of annealed or raw glass, one is of HS glass, one is of toughened glass, by looking at the glass we cannot say which one is which type of glass. So one of the traceability to the processing of the glass is through breakage, that is known as fragmentation test. If I break an annealed glass, it has no direction, it has no pattern. It can break in irregular pattern and it can harm injuries, it can create injuries also. So annealed glass will break like this. Whereas if you see a HS glass, if you see a heat strengthened glass, from the impact point, the crack will end at the opposite edge. From the impact point, the crack will end at the opposite edge, which describes it is a heat strengthened glass. The same thing when you see a toughened glass, when I impact, you can find the small granules of the particles known as fragments. If you see for an 8 mm clear glass, if I count the particles, it should be minimum 40 particles. So in this particular thing, we have got 89 particles. So through breakage pattern, we can describe whether it is an annealed glass or a HS glass or a toughened glass. To take all the three from top. Now we are going to measure the bend in the heat treated glass. First we need to measure the bend should be always measured on the longest side. So it is 2100. So next we need to apply setting blocks at the quarter positions. So what we are doing is we are giving setting blocks at 500 distance. Now visually we need to see the bend direction. Next step is we need to see visually where the bend is. So it is towards this side. Now this is a straight ruler. With the help of straight ruler we are going to measure the bend in the glass. So this is a taper gauge. Which will determine the bend levels in the glass. I am going to keep the glass straight and I am going to measure the gap or the bend between the glass and the taper gauge. If you see, it is coming 1 mm. So this is how you are going to measure the bend. So it is coming 1 mm, less than 2 mm, 1 mm, 1.5 mm it is coming. Here you can see there is no bend. Only this particular point you can find there is a bend of 1 mm. We can check even diagonally also. Cross. ऐसा पकड़िए. Glass सीधा रखिए. Now this is a diagonal measuring. glass straight. You can see it is less than 2 mm bend we are getting diagonally also. Okay. So now we are going to conduct roller wave measurement on the glass. If you see, this is a 6 mm SKN 765 glass. As the glass is passing through heating and cooling, the glass will be acquiring certain mechanical properties like roller wave, edge lift, bend and stress. Now we are going to measure what is the roller wave in this particular glass. In order to perform the roller wave, we need to have a roller wave gauge. We need to have a 1100 by 360 glass sample, and we need to make sure the glass is kept on the tinted side on top. As the glass is during tempering process, the tinted side is touching the roller, so we will get a roller impression on the tint side. Now we are going to measure the roller wave on the glass. First we need to place the roller wave gauge on the glass. We need to ensure the flatness of the table, and we need to make sure that glass is resting flatly on the surface. First we need to leave 150 mm for edge lift. Next we will be starting the gauge, the movement of the roller wave to be perpendicular to the glass direction. So perpendicular to the glass direction. Now we need to keep the roller wave on the glass surface, and we need to drag the roller wave on the glass surface to note down the reading. You can see that value is getting changed. Now it is minus 0.2, minus 0.1, minus 0.2, 0. So you can see, generally we measure the roller wave gauge. Now the roller wave is equal to, roller wave gauge is equal to the peak and the valley. As the glass is moving through rollers, it will be acquiring a sinusoidal wave, and one complete cycle will give me the roller wave. So it is a mixture of base and hardness. It is a summation of peak and the valley. So the minimum value what we got is minus 0.2, and the maximum value what we got is 0.00. So the overall roller wave is equal to 0.02 mm. The roller wave is a summation of peak and valley. It is a summation of peak and valley. So with the peak value what we got is 00, and the valley what we got is 0.02 minus. So it is a summation. So our roller wave is equal to 0.02 mm. In this particular glass, roller wave is equal to 0.02 mm. Now we are going to perform. So in order to recap, I am just re-summarizing. I am just summarizing how we are going to measure the roller wave. First, we need to take a 1100 by 360 sample as per the standard EN 1863. Next, we need to take a roller wave gauge. The placement of the roller wave gauge to be perpendicular to the glass direction. Next, we need to leave a 150 mm on the edges. Then we need to start dragging the roller wave gauge on the glass surface. We need to note down the maximum and minimum value. The summation of the maximum and minimum value will give the roller wave on the glass. The allowable roller wave as per the standard EN 1863 is 0.3 mm. Okay. Now we are going to perform the next test, that is the edge lift or edge dip. The process for this one is, first we need to hang 150 mm on the flatness surface. Next we need to take a straight edge, and we need to take a filler gauge. So we need to keep it the straight edge vertically, and we need to insert the filler gauges. We need to make sure the coating is on top. Now we are going to insert the filler gauge readings into the glass surface. Whichever scale is not going, that will indicate your edge lift in the glass. You see, this reading is not going. So this is how you are going to measure the edge lift in the glass. So it is 0.19 mm. So it is 0.19 mm. So to conclude, for tempered glass we will be doing 4 tests. First one is the fragmentation, which will determine whether the glass has been heat strengthened or toughened or annealed. Second test is the bend or bow, that will determine the bend levels in the glass. Third one is the roller wave, that is measured for the distortion levels in the glass. And fourth one is the edge lift, that the roller wave what we get at the edges. Through tempering process, we are enhancing the mechanical properties of the glass. We are not changing the physical properties of the glass. The dimensions, width, thickness, everything will remain same. Only we are enhancing the mechanical properties of the glass, through which we are acquiring strength in the glass.